Welcome students to this second part of the Fourier series analysis here. And what we want to do is basically address the question. What is the question here? The question is, let's say given a 2 pi periodic function, yes, 2 pi periodic. I will make it clear later on, not in this video but maybe in another 2-3 videos, why are we suddenly talking about 2 pi periodic functions. Okay, so let's say given a 2 pi periodic function f of x, yeah, now can we write it? Yes, can we represent it using simple functions, Now you remember in the last video we talked about this, that if f and g are p periodic function, then constant times a times f plus b times g is also going to be p periodic function, right? Yeah, so in this case you understand that if I want to talk about a 2 pi periodic function, then if I want to decompose that function, yes, then I will try to do it in terms of 2 pi periodic functions. Okay, so basically if we represent by using the simple functions, what are the simple functions in this case? So basically we will talk about this. Let's say 1 sin x, cosine x, sin 2x, cosine 2x, these are the functions, right? So if you remember, we talked about it that all of these functions are all 2 pi periodic functions, yes. So basically some combination of sum of that. So basically multiplying every one of these things with some particular coefficients and then adding it up, if it is possible, that is, then that should give us f of x. That's the question. Okay, so sin nx, cosine nx, and it goes on like this. Yes, so that is this thing. Now the thing is, this bunch of functions, you do realize they are all 2 pi periodic functions, and they called, so these 2 pi periodic functions, this is just a nomenclature. We will call that as a trigonometric system. Okay, functions form a trigonometric system. Nothing special, it's just a name. We will just talk about this system. All of this bunch of functions put together is called trigonometric system. Yes, and essentially what we want to do is, given a function like 2 pi periodic function, we want to represent that function using this element from this trigonometric system. Okay, so basically we using a trigonometric series. What do I mean by this? So see, let me put a small definition here. A series obtained using the trigonometric system, okay, metric system, we'll call it a trigonometric series, is called a trigonometric series, metric series. Okay, and what essentially is this? So essentially we are looking for something like this: a0 plus a1 cosine x plus b1 sin x plus a2 cosine 2x plus b2 sin 2x, and it goes on, right? And essentially you can make a shorthand notation of it. You can write it like this: n equals to 1 to infinity an cosine nx plus bn sin nx. Yes, so that's a trigonometric series. Clear? Now let's say that the question is this. Yes, the question is can we represent f of x using this series? So what do I mean by this? Can 2 pi periodic function be represented using the above series, okay, trigonometric series. Okay, so essentially, see what happens is this is an infinite series. So there is a question of convergence. So essentially, let's say if a series like this converges, yes, let me put it this way: n equals to 1 to infinity, an cosine nx plus bn sin nx. Okay, if let's say this particular, the right hand side of it, this converges. If it converges, then it will have a sum. Then the sum has to be equals to f of x, and this is what I mean by the equals to sign here. Yeah, we'll show that this equals to may not hold for all x. Yes, so all of that will be done later on, but for now, that's the idea of it. It's an infinite series. We want it to converge, and the sum will be provided as f of x. Okay, and this is called, okay, this, let's say this particular relation is called, so star is called the Fourier series representation. Okay, Fourier series representation of f of x, clear? And see this a1, a0, a1, b1, a2, b2, all of this, and this ai and bi, these are constants. Okay, constants, and we will call it a coefficient of the we will call it a Fourier coefficient of f of x. Constants and are called the Fourier coefficients of f of x. Okay, coefficients of f of x for all I in n union 0. I hope this is clear. Okay, now, so essentially another question is this: can we write a0, an, bn's in terms of f, that is? Okay, these are constants. Okay, but without understanding what the constants are, we can't decompose f of x, right? So there is easy formula. It's called a Euler formula. The coefficients. Okay, by the way, we will deduce all of this. Yes, the coefficients of f of x is given by the Euler formula. Is given by the Euler formula. And what is this? It is given by this. See, a naught will be given by 1 by 2 pi integral minus pi to pi f of x dx. Okay, a n will be given by 1 by pi. So the first one, the coefficient is 1 by 2 pi. The second one, the coefficient is 1 by pi. See, there is no b0. There is a reason for that, because b0 will be with corresponding to sine 0x, right, which is 0. So basically there is no b0. So a0 is there. An is 1 by pi minus pi to pi f of x. Now you will remember it like this. See, with an there is this cosine thing. So f of x should be with cosine nx dx. Okay, this holds for all n in n. And what is bn? Bn will be 1 by pi minus pi to pi f of x sin nx dx. Clear? And this is again for all n in n. Yes. So this is basically the coefficients. This will be given by Euler formula, which are these particular numbers. You can calculate all of this and you can find out what are the coefficients. Yes. Now, before we end this, we should actually say that this Fourier series, what is the origin story of it? So just a brief introduction of the origin. So as the name suggests, it was actually first of all proposed by Jean Baptiste Fourier. Okay. So he is a French mathematician. And so basically he wanted to study heat equation, right? So heat flow, basically heat flow. And to solve heat equation, essentially what happened is he actually formulated this particular notion that essentially most of the functions which you can think of course periodic nice functions, okay, we can actually decompose it using nicer functions, simple functions, okay. So for the heat flow problem, he actually proposed the idea of Fourier series. So that's the origin, okay. And this was done in the early part of 18th, 19th century, okay. So with this, we are going to end this video. Thank you.